Why am I using PostgreSQL for my platform? Why not MariaDB? Why not MySQL? For me, this isn't about hype or personal preference. When I choose a database, I look at several factors: the data model, data integrity, the feature set, scalability, operational complexity, and licensing. That last point is often treated as a footnote in database comparisons. For me, it's part of the architecture decision. Before we get into PostgreSQL, let me give you some context. I've been working with databases for many years across very different systems. I've worked with IBM DB2, Informix, Oracle Database, and Microsoft SQL Server. And then there's Teradata, the oil tanker of relational data warehouse systems, massive data sets, massive parallel processing, and designed for a completely different scale than your typical application database. I've also worked with NoSQL systems such as Apache Cassandra and MongoDB, different projects, different data models, different workloads, and sometimes completely different scales. One thing I've learned from all of that is this: there is no single best database. A database that is an excellent choice for a large enterprise system might be unnecessary, overly complex, or simply wrong for another project. Relational and NoSQL databases can also solve fundamentally different problems. So I'm intentionally leaving Cassandra and MongoDB out of this video. NoSQL deserves its own discussion and its own video. Today, we're talking about relational databases, and specifically, why did I choose PostgreSQL instead of MariaDB or MySQL? Before choosing a database, I don't start by asking, which database is popular right now? I start with a much more important question. What does my application actually need? My platform handles a lot of structured data with clearly defined relationships. In the finance part of the platform, that includes things like securities, watch lists, exchange rates, historical market data, and snapshots. Many of these entities have relationships with each other. I need transactions, I need constraints, I need indexes, and I want to run more sophisticated queries against the data. Those are pretty classic requirements for a relational database. So that brings us to PostgreSQL, MariaDB, and MySQL. PostgreSQL gives me pretty much everything I expect from a mature relational database. CID transactions, foreign keys, constraints, joins, common table expressions or CTEs, and extensive indexing capabilities. That allows me to build a clean data model and enforce important rules at the database level. If a relationship between two records must exist, I don't want to rely exclusively on my Java code to guarantee that relationship. Even good application code can contain bugs. That's why, for me, data integrity also belongs in the database. PostgreSQL isn't limited to traditional relational data. A great example is JSONB. JSONB allows me to store semi-structured JSON data directly inside PostgreSQL. And that data isn't just stored as one big text string. I can query it, I can index it, and I can combine it with relational data. That gives me an interesting middle ground. Relational structures where relationships and consistency matter, and flexibility where I actually need it. I don't immediately need to introduce another database technology just because some information doesn't fit perfectly into a rigid table structure. Another powerful feature is window functions. So what exactly is a window function? A window function performs calculations across multiple rows without collapsing those rows the way a group by operation does. That's particularly useful for historical financial data. Let's say I have a stock price for every trading day. Using a window function, I can retrieve the previous trading day's price. I can calculate price changes. I can generate rankings. I can calculate running totals, or I can calculate a moving average across a price series, and every individual price record still remains in the result set. That's the important difference compared with a traditional aggregation using group by. I can also use these queries from my Spring Boot application through Hibernate and JPA. Window functions aren't proprietary to PostgreSQL. They're part of the SQL standard and are supported by other modern relational database systems as well. But for analytical queries, they give me a very powerful tool directly inside the database. This brings us to a broader architecture question. vendor lock-in. As soon as I start using database-specific features, I increase my dependency on that particular database system. And that's not a PostgreSQL problem. The same thing happens with Oracle, SQL Server, MariaDB, MySQL, or practically any other database once you start using proprietary features or dialects. JPA can reduce that dependency. But JPA doesn't magically make my entire database architecture portable. If I use PostgreSQL-specific data types, extensions, JSONB functionality, or specialized indexing capabilities, then switching databases later may require changes to parts of my persistence layer. For me, vendor lock-in isn't automatically a bad thing. What matters is that I accept it consciously and get real technical value in return. Choosing a powerful database and then intentionally limiting myself to the lowest common denominator across every possible database isn't necessarily good architecture either. Now we get to something that's often reduced to one line in a database comparison table. For me, it's much more important, the license. A database can be technically excellent, but if I'm building a platform that may exist for many years, I also want to know, what can I do with this technology long term? How can I integrate it? How can I modify it? How can I use it commercially? And what dependencies am I creating? For me, licensing isn't just a legal footnote. It's a non-functional requirement of the architecture. PostgreSQL uses the PostgreSQL license. It's a very permissive open source license. In spirit, it's similar to BSD or MIT style licenses. For me, that means a great deal of freedom when it comes to usage, modification, integration, and commercial use. And that's exactly what I want from a technology I'm planning to use in a long-term software project. The license alone wouldn't be enough for me to choose PostgreSQL, but when a database meets my technical requirements and also gives me significant licensing freedom, that becomes a very strong overall package. At this point, you could reasonably ask, why PostgreSQL? Couldn't MariaDB run this application too? And my answer is yes, absolutely. MariaDB is an established relational open source database. I can model tables and relationships. I can use transactions, I can perform joins, and I could probably run a large part of my platform on MariaDB without any major problems. I'm not going to pretend MariaDB is a bad database just to make my PostgreSQL decision look better. MariaDB would be a technically valid choice for many of my requirements, but if I'm free to choose today, I prefer PostgreSQL. PostgreSQL gives me a very extensive SQL feature set. It also gives me powerful data types, JSONB, different indexing strategies, and a large extension ecosystem. For a platform that's going to evolve over several years, that gives me a lot of room to grow. I don't know every requirement I'm going to have 3 or 5 years from now, so I prefer a system that gives me a broad technical toolbox. MariaDB could handle many of my requirements today. PostgreSQL gives me the technical flexibility I want for where this project may go next. Then we come back to licensing. MariaDB server is licensed under GPL version 2. And to be clear, GPL version 2 is absolutely a real open source license. But it is a copyleft license. That does not mean my Spring Boot application automatically has to become GPL just because it communicates with a MariaDB database. That would be an incorrect oversimplification. But GPL and permissive licenses represent different licensing philosophies. When I'm free to choose the technology for a new platform, I personally prefer the permissive PostgreSQL license. It gives me the flexibility I want for future use, integration, and distribution. And for me, that's relevant when making a long-term technology decision. What about MySQL? MySQL is similar in some ways, but there is another aspect to consider. The MySQL Community Edition is also open source and GPL licensed. And technically, MySQL is obviously an established relational database system. It has been running enormous numbers of production applications around the world for decades, so it would make no sense to claim that MySQL isn't technically capable, but my decision involves more than pure technical functionality. MySQL is developed and controlled by Oracle, and commercial MySQL offerings exist alongside the Community Edition. So I also consider governance and long-term strategic dependencies. When I have several technically suitable databases to choose from, I prefer the PostgreSQL model. Of course, every database decision eventually raises another question. What happens if the platform grows? Choosing PostgreSQL doesn't mean I'm ignoring scalability. Before I even need to think about fundamentally changing the database architecture, I have plenty of options. I can analyze and optimize queries, I can improve indexes, I can introduce caching, I can scale the hardware vertically, I can use read replicas, I can partition tables, and I can move specific workloads into dedicated services later. For a lot of applications, that can take you surprisingly far. That leads to a broader point that I think is extremely important in software architecture. Technical complexity is never free. Every additional component means more operations, more monitoring, more backup and recovery, more security concerns, more deployment complexity, more observability, more specialized knowledge, and more potential failure modes. So I don't try to solve today the problems my application might theoretically have someday. I don't want to pay for scalability with complexity when I don't actually need that scalability yet. If the requirements fundamentally change in the future, I can evolve the architecture when that happens. Waiter here, Morgan. So let's evaluate PostgreSQL against what my platform actually needs. Relational data model? Check. CID transactions and data integrity? Check. Advanced SQL? Check. Window functions? Check. JSONB? Check. Extensibility? Check. Scalability for my realistic workload? Check. Manageable operational complexity? Check. Permissive open source license? Check. PostgreSQL covers practically every major requirement I currently have for my primary data store. MariaDB could run a large part of my platform. MySQL probably could too. I wouldn't call either one a bad database, but if I'm making the decision today, I prefer PostgreSQL. I like the technical toolbox, I like the extension ecosystem, I like the project's governance model, and the permissive PostgreSQL license is particularly important to me. So there isn't one single killer feature, it's the combination. So we're back to the original question, why PostgreSQL? Not because PostgreSQL is the best database in the world, there is no such thing. I chose PostgreSQL because it fits the architecture I'm building today, technically, operationally, and strategically. And that's really the point. A database decision shouldn't start with a product name. It should start with the problem. What kind of data do you have? What relationships exist between that data? What guarantees do you need? What kinds of queries will you run? How much operational complexity are you willing to accept? And what dependencies are you creating for the future? Answer those questions first, then choose the technology. For my platform, that decision led me to PostgreSQL. For another system, the answer could be completely different, and that's where things get interesting. Because so far we've only talked about relational databases. Cassandra and MongoDB approach data from a fundamentally different perspective. And understanding why you would choose one of those systems instead of a relational database is much more interesting than simply asking SQL or no SQL. That's what we'll look at in another video. If you're interested in real-world software architecture, database design, and the engineering decisions behind modern applications, subscribe to the channel. And if this video was useful, leave a like. Thanks for watching, and I'll see you in the next one.